Hello everyone. In today's topic, we are going to talk about independent and dependent events. So let us have some words from our past lesson. So the first word is what? Correct. It is probability. The second word is correct. It is event, and yes, it is sample space, and toss, coin, cards. So those are the words that we have in our previous lesson. Probability, event, sample space, toss, coin, cards. So let us define independent and dependent events. So two events A and B are independent if the occurrence of event A in a probability experiment does not affect the probability of event B. Two events are dependent if the occurrence of event A in a probability experiment affects the probability of event B. So your keywords or key phrase for independent does not affect. And for your keyword for dependent events is affects. So if event A affects the outcome of event B, then it is independent. But if event A does not affect the outcome of the probability of event B, then it is dependent. So here is a funny caricature in order for us to differentiate independent events from dependent. So as you can see here, in independent events, so there is a barricade in here that hinders whatever the event A is doing. So it means that event A does not affect event B. But under dependent events, since we don't have the barricade already, so event A affects event B. So it might be annoying. So his mood or feelings change already. So it does affect event B. So let us have some examples. Under the independent events, we have draw a queen from a deck of cards. Your keywords replace it, draw another queen. And then another one, roll a die and get a 6, and roll a second die and get a 3. So it does not affect each other. Under dependent events, we have draw a card from a deck, do not replace it, draw another card. So your keywords or key phrase in here, do not replace it. And then in real life, eating too many calories, putting on weight. Of course, if we eat too much, then we gain weight. So that is dependent events. Now let us try this one. Event 1 is to draw a card. Event 2 is roll a die. What do you think? Correct. It is independent. How about for event 1? Complete PAs and exam. Event 2, get good grades. Correct. It is dependent because if you complete your PAs and exam, there is a possibility that you can get good grades. Now let's move on to the multiplication counting rule. So when two events are independent or dependent, multiply the number of possibilities in each category to get the total number of possibilities. So it says here that for independent events, the probability of A and B equals the probability of A times the probability of B. For dependent events, the probability of A and B equals the probability of A times the probability of B when event A happens. So let us have from the easiest down to the most difficult. So how many ways can a person visit 4 places? So in here, you have 4 choices. If you choose one already, you have only 3 more. If you choose another one, you have 2 more. So, and if you choose another one, you have only one choice. So in here, in order to use the multiple or the multiplication counting rule, it is 4 times 3 times 2 times 1, which is equal to 24. Now, let us have another one. How many ways can someone read 5 books? So in here, we shall have 5 times 4 times 3 times 2 times 1. So you start with 5. If you choose one book, then you have 4 more choices. And then after the two books that you selected, you have three more choices. Then after the third one, you only have two more choices for the fourth. And for the last book, you only got one. So we have 5, 4, 3, 2, 1. We multiply it. It is what equal to 120. Now let us have another one. In how many ways can 5-digit ID tag be arranged if the numbers can be repeated? So in here, we have 10 choices for the digits because it starts from 0 to 9. So in here, we shall have 10 times 10 times 10 times 10 times 10 because it can be repeated. Whatever the digit you use here, you can use again in the second digit, and whatever the digit that you use for the second one, you can always choose for the third digit of the ID. So as well as the fourth one and the fifth one. So 10 times 10 times 10 times 10 times 10, it is 100,000. And in here, cannot be repeated. So we are going to have, for the first choice, we have 10. For the second digit, we have 9 choices already, and third is 8 choices. Then fourth is 7. Then for the fifth one is 6. We only stop at 6 because we only need 5 digits for the ID tag. So 1, 2, 3, 4, 5. Now let us have the third one. In how many ways can a person select 3 items from a jar with 6 items? So as you can see here, we have marbles inside the jar. We have 6 marbles. So in how many ways can we select 3 marbles from this jar with 6 marbles? First, we have with the replacement. So we have 6 times 6 times 6, which is equal to 216. We only have 3 items. So that is why 1, 2, 3. And why 6 times 6 times 6? Because with the replacement. So if you choose 1 from here, put it back again, you have still 6 choices. And put it back again, you still have 6 choices. Now, without replacement, of course, start with 6. Then, you only have 5 more choices. You have, for the third items, you only have 4 choices. So, 6, 5, 4. Why only 6, 5, 4? Not times 3 times 2, because we only have 3. 1, 2, 3. 3 items. So, it is equal to 120. Now, let us have another one. In how many ways can a license plate containing 3 letters and 3 numbers be arranged if the letters and the number can be repeated? So, in here, we have 3 letters and 3 numbers. So, we have 26, 26, 26 because we have A to Z letters. So, equivalent to 26 letters. So, we have 26 choices of letters. But because it is repeated, can be repeated, so 26, 26, 26. And then for the numbers or the digits, we have the choices from 0 to 9. So it is equal to 10. It can be repeated, so we have 10 times 10 times 10. So in total, 26 times 26 times 26 times 10 times 10 times 10, it is equal to 17,576,000. Now let us have this one. So using the same scenario, but this time cannot be repeated. So the letters and numbers cannot be repeated. So what we need to do here is start with 26, then 25, 24. We stop at 24 because we only have 3 letters. We only need 3 letters. And then for the numbers, 10, 9, 8. We stop at 10 because we only need 3 numbers. So we have 26 times 25 times 24 times 10 times 9 times 8, which is equal to 11,232,000. Now let us have the tree diagram for an independent event. So Peter has 10 colored cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random from the bag and notes the color before replacing it. So that is why this problem is under the independent event because of the word replacing. He then chooses a second cube at random. Record the information in a tree diagram. So in here, let us start with the first choice, okay? So we shall start at 3 over 10 because it says here 3 of the cubes are red. And then 7 over 10 because 7 are blue. Why 10? Because we need to add 3 plus 7 is equal to 10. Now, for the second choice, red, blue. Since it is under the independent event, whatever the outcome or probability in here, it does not affect whatever the color of your choice in the first choice. So it's still 3 over 10. For the blue, 7 over 10. For the red in here, 3 over 10. And for the blue, 7 over 10. Because he replaced it. Okay? So the number of choices or probability does not affect the first choice. Or the first choice does not affect the second choice. Now, let us have the probability of red and red. So, getting a red and red cube, we have 3 over 10 times 3 over 10, which is equal to 9 over 100. And getting the probability of red and blue, 3 over 10 times 7 over 10, it is 21 over 100. And then getting a blue and red, 7 over 10 times 3 over 10, which is equal to 21 over 100. And then getting a blue and a blue, or two blues, 7 over 10 times 7 over 10, it is equal to 49 over 100. If we try to add this one, it is equal to 1 because the sum of the probabilities is equal to 1 always. So let us have the dependent event. So in here, I use the same scenario, but this time, Peter does not replace. Okay? Does not replace the cube. Once he got it, he will not gonna put it back. That is why this problem is under the dependent event. So we start with red and blue. Of course, this is 3 over 10 and 7 over 10. We explained it a while ago already. And for the second choice, red, blue. So in here, since it is a dependent event, whatever our first choice, it will affect our second choice. So we already chosen red. So in here, it will be 3 minus 1 is 2. And then we already chose 1 cube. So the number of cubes that we have is 9. So it is 2 over 9. And in here, it is, we didn't choose blue for the first. So we have 7. But we already got 1. So it is 7 over 9. 10 minus 1 is 9. In here, we got blue at first. So in here, it is 3 over 9. Why 9? Because we already have 1 cube. So 10 minus 9. And in here, we have blue already there. So 7 minus 1 is 6. And then 10 minus 1 is 9. So we have 6 over 9. So it does affect our second choice. Okay? Our first choice does affect our second choice. That is why it is dependent. Now let us have the probability. The probability of getting red and red, or two reds, is equal to 6 over 90, while the probability of getting a red and a blue is equal to 21 over 90, and the probability of getting blue and red, it is equal to 21 over 90, and the probability of getting two blue, it is equal to 42 over 90. If you want to add this one, it is equal to 1. So that's it for now. Please do your worksheet 5 in the Google Classroom. So hope you learned something today. See you again next time. Bye.